Good morning, everybody. We are going to give it about 30 more seconds and then we're going to get started with the webinar. All right. Good morning, everyone. Welcome to Keep Culverts Well. This webinar is worth 1 PDH. And just so everybody is aware, certificates for this webinar are going to be issued sometime next week. So look for those next week. I will also put that into the chat so that that information is in there as well. We have Willy Grimke today doing our webinar. And again, it is Keep Culverts Well. And also coming up, we do have a couple of workshops starting this week. We are doing our work zone workshops that are going on. We are doing those now and through March. We also have highway school coming up, so please look for that registration. And we have several spring workshops that are going to be starting up in March. So please look for those as well. And again, certificates will be issued out next week. All right, I'm going to turn it over to Willy.
Good morning, everyone, on this chilly February morning. We're going to talk a little bit about culverts and keeping your culverts well. I looked over the attendee list, and it looks like we have several folks that are active practitioners and used to doing that kind of thing. So we're going to talk about types of deterioration and ways to preserve and extend the life of culverts. This is a Zoom meeting. Check your audio settings. Jody will be monitoring the chat and Q&A. So for this, you will receive a PDH in New York State for sitting through the hour of listening to me babble about culverts. It's only for the person registered, and you will get a certificate. I'm not sure what the case is with other states, but if you're registered from another state, check with your LTAP center there. Okay, learning outcomes. We are going to, at the conclusion of this, you will be able to discuss common deficiencies identified in culverts, describe PM of culverts, and review repair of culverts. So we're going to go with our first poll question. What is your primary job function?
All right, we are launched for that. Give it a few more seconds. Okay, share results. There you go.
Okay, it looks like 3/4 of the folks here are engineers trying to get those PDHs, but we also have 16% actually practicing highway maintenance, and then we have some others.
All right.
Okay. Okay, next. Who do you work for? Village, town, county, city, state, or private sector?
Give it a few more seconds. And there you go, Willy.
Okay, so it looks like we've got a few village folks. I am fortunate that I'm currently serving on the village board here in Greenwich. Town, we've got about a fifth town folks, 37% county, some city, some state, and some private sector. I also have, county is close to my heart as I spent 13 years with Washington County. Okay. Next, how long have you worked with highways and culverts? Less than a year, 1 to 5, 5 to 10, 10 to 20, or you're an experienced veteran and have been doing it a long time?
All right, I'm gonna end the poll. There you go.
Okay, so it looks like we've got over a third that are experienced veterans that could probably teach this. And then we've got some newbies and some novices and some, journeyman types. Okay, good. Okay, here, if you are the steward of culverts in the, 5 to 20 foot span, how many are in your inventory? None? 1 to 10, 10 to 25, 25 to 100, or lots and lots? Or, and then there's not sure.
Give it a few more seconds, let everybody answer. All right, there you go.
Okay, so we've got about almost 40% with over 100, and then we've got some not their problem, and then we've got others with differing amounts. Okay. Didn't want to do that. Okay, so we'll start off with just some general terms so everybody's on the same page with what we're talking about. With a culvert, you will have at the top, the very peak is the crown. At the bottom, where the water tends to flow through, is the invert. At the widest points is commonly referred to as the spring line, and the area of fill between the invert and the spring line is commonly referred to as the haunch. And as far as installation of culverts, that is a critical area. Continuing on in cross section, we have sometimes and sometimes not an apron, either at the inlet or the outlet coming into the culvert. Sometimes we will have a toe wall or cutoff wall, which will prevent undermining of the culvert and the apron and minimize scour. Sometimes we will have wing walls, off, often with concrete boxes. We will have a head wall or a parapet. Then we have the barrel, which is the main part of the culvert. As I mentioned in the previous slide, we'll have bedding underneath it. And if it's a pipe like reinforced concrete or corrugated metal, we may have joints every so often. Culverts come in a variety of shapes. Round is very common, but in certain conditions, we may have horizontal elliptical, otherwise known as squash pipes. Um, it seems like precast concrete boxes have become common of late. Bottomless boxes or three-sided culverts are not uncommon. You can also get a metal box culvert. Another uh, shape for when larger openings are required are pipe arches. And then we have our arches also. Culvert materials. One of the common ones is concrete. Concrete, by its very nature, is rigid. For if if we're talking about round concrete pipes in particular, The strength and durability is very much dependent on how it is bedded and how it's transmitting load from the concrete culvert to the soils beneath. Nice thing about concrete is it has a smooth interior, so water tends to flow very nicely through it. Typically, joints are in the 4 to 8 feet apart, and sometimes concrete culverts can be skewed, particularly precast concrete boxes. Here are some photos of concrete culverts. in in the upper photo, you see round concrete pipes, pair of them. They also come in horizontal and vertical ellipticals or arches. And then in the lower photo, we have a precast concrete three-sided box and or bottomless, and then also you can get precast concrete boxes. Sometimes concrete boxes can be cast in place, but it seems like of late, most commonly they're being precast and delivered. Moving on to other culvert materials, corrugated metal, which unlike concrete is flexible. And the performance of corrugated metal is very much dependent on the interaction with the surrounding soil. Unlike the concrete, where the concrete of the concrete culverts is doing most of the load carrying capacity, with corrugated metal, much of the load carrying is being done by the surrounding soils. So compaction is absolutely critical to having these perform well. And because they are flexible, if the soil moves, the culvert may move and deform over time. One of the challenges with these is they have a corrugated or rough flow surface inside, which can have some impact on hydraulic capacity. And typically with those, the joints are 20 feet apart. Here are some photos of corrugated metal culverts, a trio of round ones, and they can come in either corrugated steel, which are typically galvanized, or aluminum. Round come up to 15 feet in diameter, and plate pipe arches up to 50-foot spans, and bottomless arches up to 55-foot spans. Again, with round pipes, typically 20-foot sections. And as I mentioned before, they are flexible. Now, continuing on, another thing that's common for smaller pipes is high density polyethylene. Like the corrugated metal, it is flexible, but like the concrete, it often has a smooth interior, although some have corrugated interior. This too, like the metal, is dependent on the interaction with surrounding soil. And again, joints are about 20 feet apart. Proper installation is critical to having any of your culverts perform well and perform well over time. Getting correct bedding and getting proper compaction around culverts will minimize the probability that they will move, deform, settle, joints open, etc. And if you don't do that, the probability that you'll have to go out and open cut and replace or do major repairs is greatly increased. So let's talk a little bit about common defects in culverts. We can get debris and siltation. We can get leaking joints, settlement and sinkholes, scour, damaged coatings, invert damage, dents, cracks, spalls, and deformation of your pipe. So let's talk about debris and siltation a little bit. I wish I could say this was rare or uncommon, but with multiple pipes, it's not uncommon to see most of the flow going through one of the culverts and the adjacent one, which is meant for capacity during high flow events, getting silted up and having vegetation block it. Um, with this, you can get scour at the outlet because of increased velocities. You can get a little bit of undermining, and with siltation and vegetation essentially reducing the waterway opening during a high flow event, you can end up with overtopping that you hadn't planned on. Um, Soil and culverts can reduce your waterway capacity. Now, the caveat to that is DEC's new or recent guidance and development in many cases requires culverts to be embedded. So by design and on purpose, we may have to have some amount of soils in the bottom as the culvert's embedded. But if that's not the case, we really don't want that. Now, soil in the culverts can also be an indicator that you have joints failing or perforations, or it was installed at an improper elevation. So just keep those things in mind when you're looking at your culverts. Now, this is an extreme case of debris in a box culvert. This was the result of a dam failure on State Route 149, above State Route 149 back in July of 2005. And a huge slug of water pushed a whole lot of debris downstream. It plugged the culvert, one box of the culvert, and it did not help the water carrying capacity, and the whole structure overtopped, and this is what we were left with. So that debris got cleaned out, and that was repaired, but it can cause problems. Another issue we have is leaking joints. And as you see in the upper photo, they can be separated or misaligned, and that can result from issues with installation or other issues like scour or undermining, settlement. In the lower photo, leaking joints can result from installation damage, and you can see where there's a fairly significant spall on the bell of that concrete pipe. And the other thing that can happen is joints can open up over time in areas where you have clay soils and a concrete culvert under a relatively high fill. What can happen is those soils under the middle of the fill can settle, thereby opening up the joints. Impact of open joints is you can have water infiltration or exfiltration. And in the photo, you've got water infiltrating and freezing, which is somewhat problematic. But what's really problematic is when that water is carrying soils, causing voids to open in the and potentially sinkholes to open in the embankment in the surface above. And also the infiltration and exfiltration can destabilize our pipe bedding, causing joints to open even more and pipes to settle. And here's an extreme case with a wide open joint with lots of soil. And you can see in the invert, there's a perforation and void underneath. Uh, Pavement distress can be caused by leaking joints. This photo was taken several weeks after the road was paved, and due to the vibratory compaction and some soft soils, it created a void and little sinkhole there. And what was under that small 4-inch diameter hole was a 4 foot deep by 4 foot diameter hole that was a result of the joints opening up and water infiltrating through the joints of the pipe. We can also have scour and undermining. In this particular case, after a heavy flow event, the outlet scoured, causing the slope on the side of the pipe to subside. And now we have a major slope stability issue that was caused by scour. We can also end up with dense or localized damage. This may be caused by issues with poor installation practices. If you back your track hoe over the pipe while it's being installed, you're going to have major uh, distortions in the crown or in the pipe as a whole. It might be due to soils moving, and this could have capacity impacts. And if you're looking at doing repairs, it may limit your ability to do some sort of relining, and you may end up just having to do a replacement. Typically with relining, depending on the chosen strategy, some minor deformations can be worked around, but for major, you're looking at replacement. Here's another corrugated plate arch that has some deformation in it, and you can see that there's a belly about in the middle of the run. Cracks and spalls. This tends to be limited to concrete, and like all concrete, it may crack or spall over time. Now, if you look at where the cracking is and what's happening, it can be an indication of what's going on and what the mechanism is. If you have cracking at the 12, 3, 6, and 9 o'clock points on your pipe and it's longitudinal, that will indicate that you have poor side support and probably the sides weren't compacted adequately. If you've got cracking at the like 5 and 7 o'clock longitudinal either side of the invert, that can indicate that there was poor haunch support, or that area wasn't compacted adequately, or has been some loss of support. And if you have good side support, you shouldn't end up with any kind of longitudinal cracking. If you have radial cracks, those will indicate, depending on where the crack is the widest and opening up, whether you have inadequate support at the middle section of the pipe or at the ends. So if it's in the invert, if the widest part of the cracks are in the invert, you have inadequate support at midpoints in the pipe. And if it's at the crown, it's at the ends of the pipe. And you can see from this illustration here that with concrete pipe, which has bells, if you don't have uniform support everywhere, um, basically the concrete pipe will be acting as a beam or a girder. And where you have the most tensile stress is where it's going to crack. So if the bells are supported and there's no support midspan, you'll get cracking in the belly. And if the belly is supported, but there's inadequate support at the bells, you will get cracking up at the crown. Damaged coatings with our metal pipes. Well, typically the corrugated metal is galvanized, and that galvanization is meant to be sacrificial. The zinc is a sacrificial anode, which is intended to extend the life of the pipe, and the zinc will gradually go away, but hopefully it will take the design life of the pipe to do that. Once the zinc corrodes, um, it will then accelerate the steel corrosion, and that's when we have a problem. So the zinc going away or corroding by itself isn't necessarily an issue, but it means that it's telling you you want to think about doing something because that pipe is not going to last forever and the steel will start to corrode. Corrosion often starts down in the invert. And as you can see in the in both upper and lower photos, we have nodules, rust nodules and pitting. And that's usually how corrosion starts. And as it accelerates over time, it can lead to perforations in the pipe. And this is exacerbated with acidic or saline water flowing through the pipes. And if you have soils with low electrical resistivity, soil and water chemistry is key to the longevity of metal pipes. So before you put metal pipes in, you may want to check and see what your acidity and soil chemistry is, so you have an idea of whether those are going to last or not. Concrete culverts can have invert deterioration as well. That's typically by some sort of abrasive bed load. Certain water chemistries will accelerate concrete invert deterioration, and any kind of invert deterioration over time, if it goes through the invert, will destabilize the pipe. And here we've got some invert damage caused by basically erosion, abrasion, and we have some significant perforations in the bottom. And these are not going to be long for this world, and it's going to carry soils, cause sinkholes, and we're going to be replacing these or fixing a big hole in the road if we don't deal with this right away. And here we have settlements and sinkholes. Typically, these are symptoms of a problem like what you see here. And basically, what's happening is water is carrying soil over the culvert away. And here we have a photo of an invert that's been gone for quite some time. And we've got a nice channel underneath the invert developing. We can also get collapses. This is a photo of you know, something that was way overloaded, probably loss of cover and some kind of heavy load applied to it, and it collapsed. Now we get into we've got all these things that could possibly go wrong. What do we do to try and make our culverts last and perform? Well, we'll start out with basic PM is debris, sediment, vegetation removal, and some armoring for scour protection. So as far as getting debris and sediment out of our culverts, it depends on what you have as to what strategy you use to remove it. But the debris in this photo, there's a livestock gate here with all kinds of debris hung up on it. And then there's silt in the invert, and each one of those is going to involve a different technique for removing it. Again, type of debris, size of culvert, some like the one in this photo, you can physically enter to remove it. Some of the smaller ones, not so much. And then in any case, you'll need to follow appropriate environmental best practices so we're not creating other problems. So considerations for cleaning. Environmental, we want to contain or recover any of the silt and debris so we're not washing it downstream. And we also want to look at health and safety practices. We want to make sure we're not putting our workers at risk, putting them in confined spaces, or exposing them to contaminants in the water. So large debris, woody debris, beaver dams at the inlets and outlets. Various strategies for that are excavator with a thumb or grapple on it, other large equipment, cables, manned entry. If your permits allow, maybe putting a skid steer in. Silt removal. Vac truck, sewer jet, or water jet. When I would vac trucks are fairly effective. However, if you have a lot of volume, you're going to be taking multiple trips to empty them out. When I was at Washington County, we got the sewer district's old sewer jet, and that was fairly effective for smaller pipes. If you've got a good relationship with your local volunteer fire company, fire hose will blow stuff out. For smaller pipes, bucket line, and if you've got bigger ones and your environmental conditions allow it, small skid steer will sometimes work. If you are repairing scour, it's going to depend on the severity. You're going to want to do hydraulics calculations or consult with your hydraulics engineer for the appropriate material size. If you've got a small culvert that even under high flows has low velocity, heavy stone fill will probably be overkill. But conversely, you know, number one or number two stone may be inadequate, and you may just be sending it downstream if you've got a culvert with high flows. So you want to get the appropriate sizing. In addition to stone, you may need grout, concrete, sand bedding, geotextiles, etc. And again, you want to make sure that you have the appropriate permits. Here is a video clip of Michigan DOT placing some stone for scour repair in a bottomless concrete box. And with their own monster garage setup, they built themselves a raft with a hopper. And it looks like they have fine or light stone fill in it. Okay. And now they're floating it into place. This is how they can get it into the right along the footing, and then open the hopper in the bottom and drop it in place. Um, Another option is using a stone or riprap type apron. This is what Georgia DOT does between their wing walls to uh, minimize the amount of potential scour at the inlet or outlet. You can also use a concrete apron at the inlet or outlet to minimize scour as velocity increases as water heads into or out of the culvert. Okay, repairs. This is a little more than just basic PM kind of stuff. Um, Undermining repairs, invert repairs, joint repairs, and footing and bottomless culvert repairs, as well as relining. Um, I suspect there's a little bit of scour here at the end of this culvert, as you can see from the rod. But fortunately, this has a toe wall, which prevents that scour from advancing underneath the culvert. Now, cutoff walls or toe walls won't prevent a scour hole, but it will prevent the scour from advancing underneath and undermining. The key to having these be successful is that needs to be well below the maximum depth of expected scour. And if you have soils that are relatively pervious, this will prevent or minimize piping underneath the culvert. So, technique for scour well typically requires diverting the stream, forming that toe wall, placing concrete, and then backfilling with some sort of scour resistant material, and then restoring the stream. Invert repairs. Number of strategies for invert repairs. This is a photo of a New York State DOT concrete paved invert under State Route 29. Armor plates is another strategy that Caltrans used, although DEC may be less enthusiastic about that here. And geosynthetic cementitious mat, which is something that Virginia DOT uses. So with paved concrete inverts, requires some kind of stream diversion. The area under where the invert's going needs to be cleaned out. Any voids need to be filled, and then concrete is formed and placed, and stream flow is restored. And much more quickly and easily said than done. The photo to the left took several weeks to actually perform and install that. Armor plates, basically a new steel plate is put in the bottom and grouted into place, welded on. if you have severe abrasion, and the new plate will resist abrasion, but it will spread flow. And this is a Caltrans installation. And then there's a geosynthetic cementitious composite mat. And again, this requires stream diversion. What this is, it's two plies of non-woven geotextile with a cement cement and sand mixture in between. It comes pre mixed and installed. Basically, you roll it out, clean the invert, roll it out, and hydrate it, let the mat cure, and then restore flow over top of it. Okay, joints. In this particular photo, you're probably not going to do a lot to fix the joints here, although joint repair strategies can include internal bands, internal joint seals, chemical grout injection, and concrete collars. Internal bands are typically soil tight, but they may or may not be watertight. These were in a relining project, and these internal bands are holding the liner together, and the bands are placed over the joint and tightened with threaded rods. The challenge with these is under certain situations, you can get some debris accumulation on these threaded rods. Chemical grout injection, more commonly used for concrete. I had the occasion to see one of these being performed where we had some settlement in a box, and it closed up the joints. It's, will accommodate a little bit of future movement, and it kept soil and water from leaking into the pipe. And those are internal, and this is an external method where you basically excavate around the failed joint, form up inside, and pour a big concrete block around it, and that will keep it from leaking in the future. Relining. Various options include slip lining, shotcrete or spin cast, and cured in place pipe. And this is a photo of a Washington County corrugated arch that was relined several years ago. Relining systems include corrugated metal pipe, could be corrugated metal plate pipe or plate arch. Smooth interior metal pipe is what's shown in this photo, or HDPE. All depends on what will fit and what will maintain the appropriate hydraulic capacity for your culvert. This series of photos was performed by county crews in Washington County. And basically, the old arch that was corrugated arch was there, had been built in the 30s, and that was corroding and failing. We had some section loss, and we had some corrosion at the base of the arch where it was tying into the footing. A new footing was formed, and a slightly smaller arch was assembled and slid into place. And then the ends were formed, and that annular space was filled with grout. The challenge with this one is because the arch was on a skew and the corrugations didn't line up perfectly with the head wall, it required some additional labor to get a nice tight seal at the end to fill with grout. And basically, in this case, we could close the road temporarily, cut through the top of the old pipe, as you see in the upper left photo, and then fill with grout. For other slip line applications, if this one, the lower photo is a slip line in Saratoga County, and the pipe was inserted and then grout was injected through grout ports as shown in the lower right photo. And here's a Utah DOT photo of a slip line with polyethylene, and they had grout injection pipes at various radial points and lengths to fill the annular space between the corrugated metal pipe and the new HDPE. Another strategy is either spin casting or uh, shotcrete. Large pipes where somebody can physically fit inside, shotcrete can be used. It basically creates a new concrete interior shell, uniform thickness. Spin casting is for smaller pipes where a spin casting assembly is essentially dragged through and projects concrete onto all radially on all of the surfaces. And this is more forgiving of distortions than the slip lining would be. And like anything else, before you do it, you have to clean and grout and get everything all cleaned up before you start. Fill any voids. And here's a somebody doing a shotcrete of a odd shaped concrete culvert, and it's still a little tight for shotcrete. Relining, cured in place pipe is another strategy, and basically it's a resin impregnated belt liner. It is inserted into the pipe, and then either steam or hot water is used to cure the resin. And the liner is kind of like a sock or tube, and the insertion process and getting it in place often involves either filling it with water and a water cure or compressed air to essentially inflate it and push that liner up against the existing pipe. But while they're curing, it will take this out of service. And here is a series of illustrations of how it's done. With one of the manufacturers, they essentially have the liner inside out, kind of like when you're folding a sock, and they attach it down here to an inversion tube, and then they slowly fill it with water and then pay the pipe in, and it gradually goes to right side out. It gets filled up. The water pressure pushes it against the hose pipe, and then in this case, they use a hot water cure to cure the resin. And this is what it would look like when the inversion's complete. And then if what you see in the photo here is what the completed installation looks like. And what you have is a fairly thin-walled, polymer pipe. Okay, footing repairs to bottomless culverts. The challenge with these is that headroom and room to work is very difficult. Typically, you need some sort of stream diversion, And like any concrete repair, you want to assess the extent of sound concrete and what needs to be removed. And generally, you're going to need to go below scour depth. So in this case, a waterway diversion was put in place. You can see the concrete underneath the culvert is underneath the corrugated arch is deteriorating. All that unsound concrete needs to be removed. Any rebar needs to be repaired, and steel reinforcing put in. The area is clean, formed, and then if a bonding agent is used, that's done. Place concrete, cure out that concrete, and reestablish that stream. So we're going to go through our review questions, discuss any common deficiencies identified in culverts, describe PM, and review repair of culverts. So, question 1. Corrosion in metal pipes can lead to which of the following deficiencies?
Give it another few seconds, Willie.
Yeah, you can give this a, a little more time for people to think about what's appropriate.
All right, it looks like majority of the people have answered.
All right. Survey says all of the above. Corrosion can lead to, it can lead to invert damage. It can lead to deformation. It can lead to undermining. So yes, corrosion in metal pipes, it's telling you that bad things could happen if you don't deal with it. Okay. What would be a PM maintenance method for prevention of scour? Riprap or apron, toe or cutoff wall, slip lining or cured in place, installation of geosynthetic composite, A and B only, or all of the above.
Another few seconds. We have about 70% of participating.
Awesome.
All right.
Okay, so what we are looking for is A and B only. Riprap will help minimize scour, and a toe or cutoff well, it won't preclude the scour per se. It will keep it from being a problem. The slip lining or cast in place, if anything, could exacerbate your scour because it's very likely that that could increase your water velocities at the inlet or outlet. And the geosynthetic composite matter armor plate will probably have little or no impact. Next, what would be a is not a viable method for lining a culvert with, I'm going to say, with measurable deformation. Cured in place, shotcrete, spin cast, slip lining, or none of the above.
Another few seconds, about 60% have answered.
Okay.
All right. There you go.
Okay. So what we were looking for is slip lining would not be viable if you have measurable deformation because it's really tough to slide a rigid pipe through or something semi-rigid. Um, if you have some measurable but not huge deformations, cured in place or shotcrete will work. And if it's really major, you're probably wanting to replace it. Okay. Okay. Any questions? Um, Jody, you have on the
Yep, we had one come through. It's saying relining culverts, cure in place, debris, unsound concrete, and pipe matters
yes,
when
it
you
does.
line the pipe.
Yeah, you if you're relining, you want to a get the debris out. If you have unsound pipe or really spongy conditions, you can end up with the cured in place, for lack of a better term, an aneurysm, and it'll be bulging out to the side. So you want to kind of deal with those things before you get too far down the road. Okay, with that said, I want to I want to thank everybody for participating and listening to me drone on for an hour. I will look forward to um, those of you that will be going to any of the workshops that I'm teaching. I much more enjoy in person. And but again, thank you all, and I hope you all got something out of it.
All right, Willie, have a great day. I'm ending it right now.
Okay.